Hello everyone, welcome to my channel. In this video we are going to break down the UGC NET Computer Science previous paper of the year 2007 June paper 2. There are 50 questions in paper 2. We will cover the first 25 questions in part 1 and the remaining 25 in part 2. I will explain complex concepts in simple terms and provide tips and tricks to help you ace the exam. So whether you are a beginner or an experienced one, for preparing for UGC NET exam, this video is for you. So let's start the video. The following deterministic finite automata recognizes. So given the DFA diagram here, so we have to find out which string will be accepted by the given DFA. So if you observe here, the starting state is mentioned here. The starting state is a Q0 and the remaining two states are Q1 and Q2. So we know that a string is accepted if the string passes from the starting state to the final state. If the string reaches the final state, then only the particular string is accepted. So they have mentioned the starting state, but they have not mentioned the final state. So that's why none of the strings will be accepted here, and the answer is none of the above. Next, DFS of the following directed graph. So we need to find out the DFS path of the given graph. So in the depth first traversal, so we will start traversing from the root node. Traversing means searching. We will start searching from the root node to the child node until we found the particular element that we are searching for. So if that particular element is not found in this path, next after reaching the child node, so we will again search the remaining path. That is the DFS traversal. In the case of DFS, we will search the level wise. That is, we will first search the level 0, level 1 and then level 2. So that is in the case of the DFS traversal. Okay. So in the DFS traversal, so first we will start from the root node and next we will search the remaining child node here. Okay. So let us check the given options here. A, B, C, D, E, F. So this is the DFS traversal. So A. So first we are traversing the A, next B, C and D, E, F. So it is searching level wise. So it is not DFS, it is a DFS traversal. So next option, A, B, D, E, F, C. So A, B, D, E, F, C. And so this is the correct answer, right? So DFS traversal, it is starting from the root node, searching until the child node is found. So again, we are back traversing to the remaining nodes. So next, after D, we are traversing the remaining node, that is E, and then F, and then C. So this option is the correct answer. Option D is the correct answer. The maximum number of nodes in a binary tree of depth 10 is. So there is a formula for finding out the maximum number of nodes in a binary tree of depth here. That is 2 power d plus 1 minus 1. So this is the formula for finding out the maximum number of nodes in a binary tree of a given depth. So the depth given is 2 power 10 plus 1 minus 1, that is 2 power 11 minus 1. So this is the answer, 2 power 11 minus 1, but the option is not mentioned here, so that's why the option is none of the above. So here the formula for maximum nodes in a binary tree is 2 power d plus 1 minus 1. So 2 power 11 minus 1 is 2048 minus 1, that is 2047. This option is not given in the given option, so that's why the option D is the correct one. So next, the regular expression given below describes R equals to 1 plus 0 1 whole star and 0 plus epsilon. From the given regular expression 1 plus 0 1 clean closure. So 1 plus 0 1 here means, so this means that either it is a 1 or 0 1. So the strings in this part are made up of repetitions of 1 and 0 1. Next, 1 plus 0 1 whole star, that is the clean closure. So this allows 0 or more repetitions of 1 and 1 or 0 1. So some of the examples are 1 0 1 1 1 1 0 1 or 1 1 0 1. So this is the combination of 1s and 0 1s, right? So we are multiplying this with 0 plus the empty string, that is a null string. So this means 0 plus null means this means the string can either end with 0 or nothing. It ensures that the entire string either ends in 0 or has no specific ending. So if you combine these two parts, that is 0 or nothing with this one, so you will get the answer. The full expression matches strings that consist of any number of 1s and 0 1s followed by either 0 or nothing. So 1 0 1 1 1 1 0 1 1 1 0 1. So this must be followed by 0 or nothing. So here the matched strings are 0 1 1 0 0 1 1 1 0 and 1 0 1 0. So we are multiplying it with 0 plus epsilon, right? So then we will get 0 plus null value. So then we will get these values. So the option is a set of all strings not containing 0 0. So here in the given expression there is no consecutive zeros. There are no two consecutive zeros. So the string should not contain two consecutive zeros. The answer is option B. Which of the following language is regular? So from the given options, a power n, b power m, n comma m greater than or equals to 1. So this is the regular language wrapper. So why it is regular? Because the power n and m here, a power n and b power m, there are two different powers, and therefore there is no need of memory saving, counting and comparison. Hence it is a regular language. Since it is regular, it is also context-free language. So we can ensure that the given language is regular if it has two different powers. And there is no need of memory saving or counting and comparison here, because both the values are given with the same condition, n comma m greater than or equals to 1. So there is no need of comparison and counting also. So option C is the correct one. Okay. So here we can check. So this language has independent repetitions of A's and B's, and there is no dependency between the counts of A's and B's, and it is a finite, right? So n comma m greater than or equals to 1. This is a finite, it is not infinite. So given language is regular only if it is finite. So option C is the regular and as well as a context-free language. Next, 2's complement of minus 100 is. So we know that so 100 is the decimal value. So we have to find out the 2's complement of the negative 100. So first of all we will write the decimal value of 100, that is 0 1 1 0 0 1 0 0. So this is the decimal value of 100. So now we have to find out the 2's complement of the minus 100. Okay. So what is the 2's complement? So we have to find out the 2's complement of this particular value. So negative means we have to find out the 2's complement here. Okay. So 2's complement is, so first of all we have to find out the 1's complement here. That is the 1 0 0 1 1 0 1 1 plus 1. So we will get the answer 0 1. So this is the 2's complement of minus 100. So the correct option is option C. Okay. Next one. Which of the following expression removes the hazard form, that is the xy plus zx dash? So given the options here. So here we can solve the given expression. We can solve the given problem either by drawing a K-map or recognizing that this is just a consensus theorem, and we can add some expression here. Okay. So here in the given expression xy plus zx dash. So xy plus zx dash. Right. So what is the missing value here? So in the first term, so z is missing, and second one y is missing, right? So we can remove the hazard here easily by writing the missing terms here. So xy into z plus z dash and x dash z into y plus y dash. Okay. So if you open this parenthesis, xyz plus xyz dash plus x dash zy plus x dash y dash z. So we need to draw the K-map for the given expression. So if you draw the K-map for the given expression, then we will get this mappings. Okay. So how to remove the hazard here? So we need to add a redundant term here, right? So what is the common redundant term? So this one is a redundant term. So this will make an extra pair in the K-map that doesn't contain the variable x. Okay. So if you write down this value, so here we will get the xy plus zx dash plus, so what is the value here? Yz, right? So xyz and x dash yz means yz. So yz. So in this sense we will get the answer. So there is also another way to get the answer by checking the each and every options here. So I am taking the option C only here directly, and I will prove that so the given option is correct by using the consensus theorem. So xy plus zx dash plus yz. Okay. So we will consider the yz with this 1. So xy plus zx dash plus yz into x plus x dash. So if you open the parenthesis here, so we'll get the xy plus zx dash plus xyz plus x dash yz. So now we can write this one as xy plus xyz plus x dash z plus x dash yz. So if you take the xy common here, xy into z plus 1 plus x dash z into y plus 1. So z plus 1 is 1 and y plus 1 is 1. Okay, so we'll get the xy plus x dash z. So hence proved from in the reverse way also. Okay. So next one. How many ones are present in the binary representation of 15 into 256 plus 5 into 16 plus 3 base 10? So if you perform the arithmetic operation of this given expression in decimal value, so we'll get the answer as 3923. So if you find out the binary value of this one by repeatedly dividing the given number by 2, so we will get the remainder. Right? So if you read the remainders from bottom to top, then so that like 3923, right? So by 2, that is 1961, and again divide this by 2, that is we will get the 980. Okay. So here we will get the remainder 1, and here we will get the remainder 1. Okay. Next 2 4s are 8, 2 9s are 18. So we will get the remainder 0. So like this we will keep on repeatedly divide the given number by 2 until we get the remainder, until we completely divide the given number. So read the remainders from bottom to top. Then the binary representation of 3923 will be, so what is the binary representation here? That is 1 2 3 4 0 1 1 0 1 1 0 1. So this will be the answer here. So in the given answer we have so we have 4 ones, 1 1 1 0 1 0 1 double 0 double 1. So this is the answer. So this will be the answer here. So if you calculate, so here they are asking what are the number of ones present in the binary representation of a given decimal value 3923. So here number of ones are 8, right? So that's why the option A is the correct one. If A XOR B equals to C, then so here we have to go through the properties of XOR, commutativity and associativity. So A XOR B equals to B XOR A, and the associativity property. So A XOR B XOR C equals to A XOR of B XOR C. So this is the commutativity and associativity property of XOR. Next, identity operation. A XOR 0 equals to A. And self-inverse operation. A XOR A equals to 0. And inversion property, that is A XOR B equals to C. And so this implies A equals to B XOR C. And B is equals to A XOR C. So these are the properties of the XOR operation. So option D is the correct one. So in XOR operation, if A XOR B equals to C, then A XOR B XOR C equals to. So what will happen? A XOR B XOR C. So if you substitute the C value here, so C XOR C, that means 0. So option D is the correct one of the ninth question. What is the maximum counting speed of a 4-bit binary counter which is composed of flip-flop with a propagation delay of 25 nanoseconds? So here each flip-flop has a propagation delay of 25 nanoseconds. And a 4-bit counter is a ripple counter where each flip-flop triggers the next. So to find out the total delay here, so we need to multiply the bit counter with the propagation delay of a flip-flop. So here so using the 4-bit counter, so multiplied by the propagation delay of a flip-flop. Then we will get the 4 into, what is the propagation delay here? It is given as 25 nanoseconds. So 4 into 25 nanoseconds is equals to 100 nanoseconds. And we need to find out the maximum counting speed here. So to find out the maximum counting speed, we have the formula, that is 1 by total delay. Fmax equals to 1 by total delay. So what is the total delay that we obtained here? 1 by 100 nanoseconds. Okay. So we can write the 100 into nanoseconds as 10 power minus 9 seconds. So we are converting the nanoseconds into seconds. That is 10 power minus 9 seconds. That is 1 by 100 into 10 power minus 9 seconds. Okay. That equals to 10 megahertz. So we know that time is the inverse of the frequency. Frequency and time are inversely proportional with each other. That's the 10 megahertz is the answer. The following loop in C. The following loop in C. Int I equals to 0 while I plus plus less than 0. I post decrement. Okay. So option is D. It will go into an infinite loop. So first of all, we'll check this given C program here. I is given as 0 and while I post increment less than 0. So post increment means, so after performing this, executing this statement, we will increment the I value. So I value is 0. So 0 less than 0. So which is false. So we'll come out of the while loop. So next, so after coming out of the while loop, I will increment. So I value will become, so I value will become 1. So I value will become 1 after coming out of the while loop. So 1 post decrement. So here I value is 1 and post decrement. So we are again decrementing the value here by 1. Then it will become 0. So again when we go to the starting of the program, so I value will become, again it will become 0. So now again we will check the I value. So I is 0 post increment less than 0. So post increment means after executing this particular statement, it will increment the value. Okay. So 0 less than 0 is false and it will come out of the loop and I will increment here. So again it will be 1. So 1 post decrement, that is it will again become 0. So this loop will go into an infinite loop. So this will be keep on changing here. 0 to 1 and then 1 to 0 and 0 to 1 and again 1 to 0. So this is an infinite loop. So option B is the correct one. Next. In case of right shift bitwise operator in C language, after shifting n bits, the leftmost n bits will, so the leftmost n bits will be obviously filled by zeros. Okay. So it will be obviously filled by zeros or ones and it is the machine dependent. So the behavior of the right shift operator in C depends on whether the type of the number being shifted is signed or unsigned. So here they have not mentioned whether it is a signed bit or unsigned bit. If it is an unsigned bit, then the right shift will always fill the leftmost bits with zeros. The leftmost bits will be filled by zeros. If it is an unsigned bit. And if it is a signed bit, the behavior will depend on the machine and the compiler. So the right shift is an arithmetic shift, which means the leftmost bits are filled with the sign bit, that is 1 for negative numbers and 0 for positive numbers. If suppose the right shift is a logical shift, it means the leftmost bits are filled with zeros. So it will depend on the unsigned or signed bits. If it is an unsigned bit, then the leftmost bits will be filled by defaultly by zeros. If suppose the given number is unsigned data, signed data type, then the leftmost bit will be filled by the sign, that is the positive or negative sign, or if it is a logical shift, then it will be filled by zeros. Okay, so the answer is option C. What keyword in class specification helps to hide the data? The answer is B, private. So in the public, any class can refer to the field or call the method. Whereas in the private class, only the current class will have access to the field or method. So option D is the correct one. What is the output of the following C program? Main, so printf %x -1, left shift 4, right shift 4. So here given the right shift operator and %x means, so it will convert the, it is a format specifier in the printf to print the value in hexadecimal format. So -1 right shift 4. So first we need to convert the -1 in binary format. In most modern systems, integers are typically represented using 2's complement. In 2's complement, -1 is represented by all bits set to 1. So if you are assuming an integer is 32 bits long, then so it will be like so we will have 32 ones here consecutively. So 32 ones will be placed here. Okay, and so on after 32 bits. And right shift by 4 bits. So one is so we need to right shift by 4 bits. So right shifting by 4 bits means moving all bits 4 positions to the right. So we are moving the bits position to the right. Since -1 means all ones, right shifting it will still result in all ones. Okay. Okay. So if you are right shifting the given ones by 4 bits to the right means so it will result in ones only, all ones only. So here the format specifier is printf %x. So %x means that to print the value in hexadecimal format. So we need to print this value in the hexadecimal format. So how do we print this value in hexadecimal format? So the output of the given C program will be 4f. So hexadecimal format is 4f. So the correct answer is A, that is 4f. So option A is the correct one. Runtime polymorphism can be achieved by accessing virtual function through pointer of the base class, accessing virtual function through the object, the derived class, none of this. So you need to provide a virtual member function in base class and override it in derived class. The actual method type of the object pointed by the base class pointer. So option A is the correct one. Which of the following statements is wrong? So here the wrong option is option C. So timestamp protocols suffer from cascading rollback, whereas the two-phase locking protocol do not. So cascading rollback is possible under two-phase locking protocol. To avoid this, follow a modified protocol called strict two-phase locking protocol. Here, a transaction must hold all its exclusive locks until it commit or aborts. Timestamp protocol is not recoverable and can lead to cascading rollback. So using locks that block process two-phase locking protocol may be subject to deadlocks that result from the mutual blocking of two or more transactions. So option C is the wrong one here. Next, a recursive foreign key is. So we know that a foreign key is a field in one table that uniquely identifies a row of another table. In addition, the child and the parent table may in fact the same table. That is, the foreign key refers back to the same table. Such a foreign key is known as a self-referencing or recursive foreign key. Suppose normally if a key is if the primary key in the given table is pointing to another table, so then it will become a foreign key. A foreign key is a field in one table that uniquely identifies a row of another table. Okay, so it will become the foreign key. If suppose the given foreign key is referencing itself, if the table is self-referencing itself, then it is called as a self-referencing or recursive foreign key. Okay, so option C is the correct one. It references its own relation. So this type of recursive foreign key is actually used in hierarchical structures like organizational charts or tree structures. And recursive foreign key means when a table has a foreign key that refers the primary key of the same table. A subclass having more than one superclass is called. So it is called as a category. So here a subclass is having more than one superclass. That means, so here it is following the inheritance. Okay. So multiple inheritance. So here a subclass is having more than one superclass. So we have more than one superclass for the subclass. Okay. So certain situations require the modeling of a superclass or subclass relationship with more than one distinct superclass. This subclass having more than one superclass is called a category, and the process of defining a category is called as a categorization. So this is called as a categorization. So option A is the correct one. Next, a relation R equals to A, B, C, D, F. So this is the relation here, and given set of functional dependencies which of the following is the candidate key? So we need to find out the options here. We have to check each and every option. A closure. So A closure means, so what is followed by A? So A is followed by B, and B is followed by F, and A is followed by E. Right. That's all. Next, AC closure. So AC closure equals to AC. AC itself, and then A followed by B. So B, right. Next B is followed by F, and then A is followed by E, right. So now it is also a candidate key. So this one is not a candidate key, and this is not a candidate key. So next we will check the AD whole closure. So it will followed by AD itself, and then AD implies C here, right. So ADC, and A is followed by B, and B is followed by F, and A is followed by E. So this is a candidate key because it is satisfying all the values in the relation. So A, B, C, D, E, F. So option C is the candidate. Which statement is false regarding the data independence? So option C is the correct one. Relational model suffers only from the logical data independence. So what is meant by data independence? So in the hierarchical structure, so we have the three types of hierarchies, right? So that is the view level, conceptual level, and the physical level. So that is the view level, conceptual level, and the physical level. So between the physical level and conceptual level, we have the physical data independence. Whereas between the view level and the conceptual level, we have the logical data independence. Okay. So only the relational model suffers from the logical data independence. Okay. So it is not possible in the remaining one. So option C is the correct one. Option C is the correct one because here given relational model suffers only from logical data independence. So it has a relation has both the logical and physical data independence. So that's why the option C is the false regarding the data independence. The time required to find the shortest path in a graph with n vertices and e edges is. So in the given problem, they have mentioned that we have to find out the time required to find the shortest path between the n vertices and e edges. So they have not mentioned any algorithm here. So we have different types of algorithms to find the shortest path in a graph. That is the Dishitra algorithm, Bellman-Ford algorithm, Floyd-Warshall algorithm. So we find the shortest path from a single source vertex to all other vertices in a weighted graph with non-negative edges in the case of the Dirichlet's algorithm. So in the Dirichlet's algorithm, so we will find out the shortest path from the single source vertex to all the vertices here. So here it is a non-negative edges. Only we will find out the values for the non-negative edges. Whereas in the case of the Bellman-Ford algorithm, so it will find the shortest path from a single source to the multiple edges here for negative edges also. For negative edges also, it will include the negative edge weights. That is called for the Bellman-Ford algorithm. Whereas in the case of the Floyd-Warshall algorithm, so it will find the shortest path between all pair of vertices in a weighted graph. Okay, so Floyd-Warshall will find out the all pair shortest path here, Floyd-Warshall, in a weighted graph. Okay. So here the time complexity of Dirichlet's algorithm is big O of n plus e into log n. Whereas the time complexity of Bellman-Ford algorithm is big O of n into e. The time complexity of Floyd-Warshall algorithm is big O of n cube. Okay, so here they have not mentioned any shortest path algorithm here. So basically, we will take the Dirichlet's algorithm here. Okay, so here they have not mentioned. So normally a shortest path algorithm is Dirichlet's algorithm is considered. If the problem refers to the shortest path in a graph with n vertices and e edges and doesn't specify the algorithm, then the most commonly used algorithm is the Dirichlet's algorithm with the big O of n plus e log n. But this option is not given here directly. Okay. So we will consider the here the sparse graph and the dense graph. In the case of the sparse graph, so the option is big O of e. So here n and e will become equivalent. And in the case of the dense graph, so here the edges will be approximately equals to the n square. So it is equivalent to n square. So in the case of dense graph, it will become big O of n square. Whereas in the case of the sparse graph, it will become big O of e. So in this way, if we consider, we will get the answer, that is the option D is the correct answer. So they have not directly given the options here. So they have indirectly mentioned the options here for dense and sparse graphs. Next, pre-order is also known as. So pre-order is one of the depth first traversal methods. So option A is the correct one. The equivalent postfix expression for D by E plus F plus B into C is. So now we will find the postfix form of the given infix expression. So D by EF plus. So in the postfix, the operand will come first, then the operator will come. So EF plus BC into. So first the operand will come and then the operator. Okay. Then close the parenthesis. So now, so first of all we have to take the operand and then operators. So D E F divided by DEF plus divided by plus BC into. So we'll get the operator here outer. So the first the two operands will be considered and then operator. So DEF plus divided by BC into and then the operator plus. So this is the correct answer. So DEF plus divided by BC into plus. So option C is the correct one. Which algorithm has same average, worst case and best case time? So maximum of n numbers have the same average, worst and best case time. So here the binary search, the best case is big O of 1 and average case is big O of log n and the worst case is big O of log n. Okay. So there is a difference between the average, worst case and best case here. And maximum of n numbers has the big O of n as the time complexity for all the cases. And fix out here best and average cases are same and the worst case is different. And for the Fibonacci series, best case is big O of 1 and average and worst case are big O of log n. So that's why option B is the correct one. Application of data structure in Q is, so it is the B, polling. So we use the queue in the polling. A priority queue can be implemented using many of the data structures that we have. However, those data structures do not provide the most efficient operations. To make all the operations very efficient, we use a new data structure called heap. We can implement a priority queue using 2 queues. So this is about the first 25 questions in the UGC NET question paper of June 2007. So we will see the remaining questions in the next part. Thanks for watching my video.